Let's start off with a couple of problems with a camera. So for a camera, what we have is we have an opening, which we call the aperture, that has a fixed diameter. And we can change the diameter, decrease the aperture down. That reduces how much light comes in. And so if we reduce the size of the aperture, we're going to need to leave the shutter open for more time so that we get the same amount of light in to expose the film. So what we're told is that when the aperture is equal to f/4, then the correct shutter speed is 1/250th of a second. That's pretty fast. And let's say if we now change the aperture to f11, what should our new shutter speed be? Okay, so the shutter speed is a time, and this f11 is basically a diameter of the opening. So the amount of light that comes through should be proportional to the area of the opening. Okay, so the area of the opening is proportional to the diameter squared, and so the time that you need to have it open for should be inversely proportional to the area. So it should be inversely proportional to the diameter squared of the opening. So what do I mean by f4 and f11? Well, it's the ratio of the focal length of the lens. So let's say I had I don't know, 100 millimeter lens. So its focal length is 100 millimeters. So then f4 would be 100/4, or 25 millimeters. So the diameter of the opening would be 25 millimeters. f11 would be 100/11, and so that would be just over 9 millimeters. So f11 is a smaller opening, and so we should have to have the camera open for a longer time in order to get the same amount of light through. Okay, so how does the diameter compare? So let's call this 1 and 2. So the diameter for 2 is f11. The diameter for 1 is f/4. So if I look at the diameter of 2, it's equal to, well, let me take a ratio. So if I take a ratio of d2/d1, that's f/11 divided by f/4. Right, so the f's cancel with each other. I get 4/11. So d2 is equal to 4 times d1/11, which is d1/2.75, it turns out. Okay, so since the time is proportional to 1 over the diameter squared, time 2 should be proportional to 1 over the diameter 2 squared. So that should be proportional to 2.75 squared, which is 7.56. So the time should be 7.56 times longer with the smaller opening. So I had T1 was 1/250th of a 1/250th, sorry, of a second. So T2 is equal to 1/250th times 7.56, which turns out to be 0.030, which is about 1/30th of a second. So it's all a matter of ratios. You just need to think about it. You might do the math a different way, but you should come up with a shorter time for a wider opening and a longer time for a smaller opening. Okay, so now I've got a telephoto lens that's got a focal length of 135 millimeters. I'm told it has f numbers ranging from f2.8 to f22. So f2.8, that should be a wider opening. f22 is a very small opening. So we want to know what's the diameter of the lens aperture. Well, I already worked something like that, an example for 100 millimeters. So D for, I don't know, let me call it D 2.8. It's going to be 135 over 2.8. So 48.2 millimeters. That's about 2 inches. The diameter for a 22, F22, would be 6.1 millimeters. Okay, so just over half a centimeter, just over a quarter of an inch.